Yo, what's good, guys? Today we're gonna be playing, or we're gonna be solving input trie. So this is a prefix tree. If you guys don't know what this is, it's good for like making words, but out of like a tree. I'll show you guys what it would look like. So let's say we have a prefix tree, right? Let's go ahead and write it out. Prefix. All right. All right. So we're gonna have something called like a root node. Well, this node is always gonna be empty, right? But then we don't really care about what is actually inside this root node. We care more about its child. So let's say we're trying to insert a word. Let's say I don't know, soda, right? We want to insert the word soda into this prefix tree. We'd go ahead and just put one of its childs as an S, right? And then that one has another child, which is O, and then one that's D, and one that's A, right? And because A is the last letter in the word soda, we go ahead and just label it. We could label it like like a star, or actually, let's go ahead and just label it saying last, right? Let's say there's another word starts with an S. Let's say snake, and we want to go ahead and insert this, right? We wouldn't just open up a new node, a new child with an S, because we could see that soda and snake both share one letter, and that letter is S. So instead of just making like a new child for the root node, we go ahead and just use the child which is already made and just branch off of it. So it'd be snake, SNAKE, right? And we go ahead, and because E is the last letter in the word snake, we could go ahead and just label it as last. Right, so our job for this question is basically just implement a trie, which is a prefix tree. So we basically just have to make this. There's other operations such as like to check if it's there. So one of them is going to be prefix of let's say so, right? We can see if so's there, and we can see from the tree node we could see that there's an S, so that's checking that. And let's see if there's an O. Yes, there's an O, and that's correct, so we could just return true, right? But if we use something called like is there, we could see that so would not work because the O in so is not marked as the last letter. So yes, it is a prefix, but is it a word inside the prefix tree? No, it's not. Just because it didn't have that label saying last. Let's see what else is there. There's so insert. We could insert a letter, which is kind of like what we did earlier. So if we're trying to insert like cat, right? We could see this does this root node right here have anything with a C as a child. So we can see that there's an S, but there's no C. So we go ahead and just add it, right? And then just add A, and then add T, and then go ahead and label T as the last letter, all right, as the last. We have a Boolean, just the search. Yeah, let's see. So Boolean search is what we were talking about. Like if we use so would not be there. It would return false, right? Well, starts with it would be true, right? The difference being is that one is marked with last, and the other one is not marked with last. So let's go ahead and try to solve this question. So to solve a prefix tree, right? A prefix tree consists of nodes. So we're gonna have to open up the class and just name it node. Um, so with node, we're gonna have initializer. Okay. And what do we have? We have self dot children. And we'll just have this be a, let's make it a dictionary. And the dictionary be the letter. Let's see, let's go ahead and write it out. Key would equal the letter. And then we could say the value is going to be equal to, let's go make it the node, a node class. What else does it have? So it has children's. We should have something like, remember how we were talking about how something is marked as last? Well, we could just turn this into a boolean, like true or false, right? We could say is last letter, right? And we could have it bool, which means either true or false. Right, okay, let's go ahead and do that. So self is last letter is equal to, let's go ahead and initialize it as false because we could switch it to true later on. But yeah, most letters that we be adding will not be the last letters, so that's why we have false. And I think that should be good. Initializing something should just call self.root is going to equal to, we'll just call class node once. Right, initially I'll have no children and no anything. Let's go ahead and insert a letter. So we're given a word, and that word is a string. So we could say for each character in word. So for each character in word, we want to go ahead and insert it. To the tree. Before we do that, we have to check, right? Let's say if character in self.children if the character is already in self.children, then what do we want to do? We want to say, actually, we will kind of have like a current pointer. So we could say current is equal to self dot we want to make that root self dot root, which is the main node. Okay, for character in word. If the character is already in self.children, I want to say current. Right, if it's already in current.children, then we could go ahead and let's see, we go back to this. Let's go ahead and implement our node, draw it out again. Let's just say this is our empty. We'll call this root, R for root. Okay, so let's say we wouldn't put the word cat. Right, so the word cat, I kind of made that ugly. Let's go fix it out. And we'll say this is true. Okay, and let's go ahead and see. So cat is inserted. So cat is one of them. Let's say if we want to could insert something called could. So if it's already in here, then we could just switch current to the current character. So you want to actually add O because we're trying to add could. Actually, no, we don't check if it is. If character not in current.children. Let's say if we want to add something like Apple, app. We want to add app. Right? We see it's not in children, so we go ahead and just add it as a node. So you create a node. Self.root equals node. Okay, so we could say node with C. Right. Is that how you make it? If character not in current children, we're gonna make a node called character. Then we want to go move that so current is equal to wait, I want to say children. Is going to be equal to node of and then regardless of that, we want to move over to that one. So we current is equal to node okay. And then after that, we want to mark our current. Current dot is last letter. So for each character, you want to do that, and then when you do current is last letter, because we should be at the current last letter, we do true, then okay, that seems pretty good. I think we want to do the same thing for search. So we could say current is equal to self.root. Then we could do for each character in the word that we're given. We just have to search for it. So if the character not in current dot children, then we just return false. And if it is, then we're gonna do current is equal to current dot for each character in the word. If the character in that word is not in children, then return false. This is assuming that it did. This line assumes it's been found. Current.children and add that character. Okay, let's see what else. So we do that, and after we've done this until everything has been found, we check if we go ahead and just return. We go ahead and just return current dot is last letter, right? Because we want it to be the whole word. And we could go ahead and just use this same thing because it technically is the same. We go ahead and use the same thing, except instead of returning if it's the last letter, we could just return true. I think this is pretty good. I might have had some syntax issues, but let's go ahead and test it out. I'm gonna have the test run. Okay, so takes one positional argument, but two are given. Hmm. Like I said, that's line 97. Right here, okay. So current children. So we create a new node with a character. Huh. I kind of want to know. I think I might have made a syntax issue. Mm. Mm. Okay, let's try this now. Okay. I think it was that one line right here. Is equal to node? We're not supposed to specify. Yeah, that's what I thought too. How do we set node? Oh, I think that's it. Okay, yeah, we did it. I think I was putting the character in here, right? But then the character is already here because that's the key, and the value should just be an empty node. Yes, I get it now. Okay, well that's how you go ahead and solve, implement trie, which is a prefix tree. Hope you guys understood it. Um, that's my solution for it.